Hey there. So, if you have not done so already, I need you to press pause, please, and complete the warm up. I'll probably talk you through number one just to make sure that you're okay. And then we will do number two, but try it first. And then, if you need a little assistance, that's where this video comes in. So, graph each function rule using a table of values. That means the table that's provided on here is what I need to use. My typical numbers for doing so are going to be -1, 0, and 1. And I'm just going to plug in each of these values into the equation and then see what I get. So when I plug in -1, I get y equals 5 times minus 2 times -1. 5, order of operations. Multiplying here, I have +2, so that's going to be 7. And then when I plug in my most favorite number in the world, I'm going to have 5 minus 2 times 0. That's 5 minus 0, which would be 5. Now looking at the pattern, I would think that my next one, because this is minus 2x, should be 3. You can plug that in to make sure if you don't believe it. Next step is to graph this. So I'm going to treat each of these as a coordinate, remembering that the x part tells me to go left and right, and the y tells me to go up or down. So this as a coordinate is -1, 7. So from 0, 0, I'm going to go 1 to the left, and then up 1, 2, 3, 4, 5, 6, 7. 1, 7. And then you're going to graph each of the other ones as well. So 0, 5, and then 1, 1, 2, 3. Now, if you don't have one yet, go ahead and press pause. That's what it's there for. We love it. It's our fun. To go ahead and grab a straight edge. If you don't have a ruler, just use your student ID card. It works pretty well. There you go. And now this is a function, and the name of this function is y equals, ooh, that's weird, 5 minus 2x. Label it. Gotta label it. Now, number two, I could freak out because there's a fraction here, or I can make my life easier by being smart when I deal with them. So if I don't want to deal with fractions for this whole entire time, I can get rid of them. So instead of using -1, 0, and 1, I'm going to use -3, 0, and 3, because I have this 3 in the denominator and it's going to make it cancel out. Here's how. So cancel, cancel. This is positive times a negative, so -1 minus 4, which equals -5. And then when I plug in 0, I have 0 minus 4, which is -4. Looking at the pattern here, this should be -3. But I'm going to invite you to go ahead and plug it in right over here, and then make sure that you get the same thing as me. When you're done, please do me a favor and graph each of these points. Okay, so if you pressed pause, and you should have, then you would have confirmed that you get -3 for 3, so this is this point right here. And then for each of these coordinates, for each of these coordinates, you graph each one, and then you connect your dots there because you're graphing the whole row. So go ahead, if you didn't press pause, do so now, and make sure that you have this graph on your paper. All right, the next thing that we're going to talk about here is continuous versus discrete. Continuous is a graph whose graph is unbroken. So it's unbreakable. It's going to be continuous from point A to point B. There's no stops, there's no broken points, there's no breaks in it. It just goes on and on and on. Discrete, on the other hand, is composed of distinct isolated points. So instead, you would just have specific points. Just a point, and a point, and a point, and a point. And you're not going to connect those ones. I think of continuous and discrete when I think of my mom, because the way that she communicates is 100% continuous, and the way that I communicate typically is more discrete. For example, I might ask my mom, like, hey, you going home right after work today? And then she might say, well, I don't know, because first, I need to go and get gas, and then after gas, I'm going to go to Target because I'm out of milk, and I need a little bit more milk, and then I'll probably go over to see Grandma after that because, she wasn't feeling too well. And there's this great big old long story that feels like it's going on and on and on and on and on. But what I ask, going straight home, yes or no? This is a yes or no person. This is all the points in between type of a person. Different people communicate different ways. But for graphs, that's what that should look like. So we're going to do a couple of these. And my directions are graph each rule, tell whether the graph is continuous or discrete. First one I'm going to look at is the cost C in dollars for a health club membership depends on the number M of whole months you join. This situation is represented by the function C equals 49 plus 20M. So the first thing they asked me to do was to graph the rule. To do that, as we've done in previous ones, I'm going to make an XY table, except instead of X and Y, I have C and M. Well, what am I plugging in? Am I plugging in the C values? No, I'm plugging in the M values in order to find out what C is equal to. So if I decide not to go, or the first month rather, the 0 month, for 0 months, I'm going to pay $49. That $49 is my initiation fee, basically. I have to pay that before I even start going. So then after the first month, I'm going to pay that fee plus another $20. So the first month is 49 plus 20 times 1 because it's the first month. So 49 plus 20 gives me 69 bucks. Then after my second month, I'm going to add another 20 to that. So 49 plus 20 times 2. 49 plus 40 is 89. And then you should kind of start seeing a little bit of a pattern. I'm 20 times a month, so it's $20 per month, but the third one I'm going to add another $20 here. I have 109. From here, I believe we can graph it. So I'm going to go ahead and start with my X and Y table. And when I draw my X and Y, one thing I'm not going to do is worry about having too much room on the negative side. Because at the end of the day, no one cares. I can't pay for negative months of going to the gym. And they're not going to pay me to go, so I'm not going to have negative cost either. Unless I slip and fall and hurt myself or something. So let's remember this was the C, and this was your month. And my numbers kind of go up pretty quick, but there is a pattern from here to here. So in my mind, I'm thinking, okay, it'll be great if I can go by 20s. But to signify that, I'm just going to break here, make a break. That's the zigzag part. And then for 0, 49, I'm going to make this first line be 49, then 69, then 89, then 109, then 129, 149, 169, 189. And the number of months, well, there's 0 here, then 1, 2, 3, 4, 5, 6, 7, 8. So at 0 we said was 49. And then for your next one, at 1 month is 69, 2 months, 89, 3 was 109, 129, 149, 69, and 189 for month 7. Now, here's the question. Should I connect these or should I not? Do I break out the ruler, the straight edge, or not so much? Well, M is the number of, going back to this original problem, the number of whole months that you join the gym. So that means I'm not going to have to pay for half a month. I'm not going to pay for 1.5. I'm not going to pay for 2 months and 1 week. It's only these specific points. So I'm not going to connect the dots because I can't have half a month. They said whole months only. So nothing in between here, just the whole numbers. Okay, check that. And then make sure you have what I have. And if you don't, take a moment, take pause, and then write it down. Okay, for number 2, the cost C in dollars for bananas depends on the weight W. So now the cost C depends on the weight W in pounds. This situation is modeled by the function C equals 0.5 W. And what we would need to do is to create another XY table. So I have my W and I have my C. And then we're going to plug in some values. So what's the smallest amount that I can buy? I think I can buy 0. I can decide I'm going to save my money and not buy any bananas today. I could also buy 1 pound. I could buy 2 pounds. I could buy 3 pounds, whatever I really want, actually. So, but if I buy 0, 0.5 times 0, that means I'm not paying any money. If I buy 1 pound and it's $1, if it's 50 cents per pound, then the cost is going to be 0.5 times 1. So I'm going to pay 50 cents. 0.5. For 2, it's 0.5 times 2, which would be 1, because 2 halves make 1 whole. The next one, if I'm following the pattern, should be 1.5. And for 4, I should get 2. All right, looks fine and dandy to me. Let's go ahead and plot these points on our thing. So again, for this situation, because I can't deal with any negatives, I'm going to go ahead and make my first line right here. Oh, that's horrible. And again, this is your W, this is your weight, and this is your cost. So the more that I spend over here, the higher my cost should go. So if I spend 0, I don't buy any bananas, then that's 0. Then for 1, it's 1.5. I don't know that I want to deal with these decimals. So what I'm going to do instead is I'm going to make this first value right here 0.5. And then my next one will be 1, then 1.5, then 2, then 2.5, then 3, then 3.5, then 4. Okay. Then you can go ahead and plot each of those points. So 0, 0, oh, this is 1, 2, 3, 4, 5, 6, 7, 8 pounds. And then you're plotting and you're plotting and you're plotting and you're plotting. And then you're going to ask your question, is this discrete or continuous? The last one was discrete because we couldn't connect those dots. It was just distinct points only. For this one, you're talking about weight. So if I go to the store and I want to buy some bananas, yes, I can get 0. Yes, I can get 1. But can I get a half a pound of bananas? Can I get 2¼ pounds of bananas? Can I get 3.1 pounds of bananas? I can. It doesn't have to be the exact amount. So because I can get points in between, I'm going to go ahead and graph this whole thing because everything counts. It's not just the distinct ones, it's everything in the whole wide world. All right, so that is that, beautiful people. And you can go ahead, check through these notes, make sure you feel good about them before you go on to your next video. Thank you so much.